Our solar system is a fascinating place. At its heart lies the sun, a giant ball of burning gas. The sun is a star just like the ones we see twinkling in the night sky. It's a giant nuclear reactor that produces an incredible amount of energy. This energy, in the form of light and heat, reaches Earth. It makes life on our planet possible. The sun's gravity is what holds the entire solar system together. It's like an invisible string that keeps all the planets, moons, and other objects in orbit. Without the sun's gravity, everything would fly off into space. The sun is the most massive object in our solar system. Its gravity affects everything else. The sun is mostly made up of hydrogen and helium. These are the two lightest elements in the universe. Deep inside the sun, hydrogen atoms are constantly fusing together to form helium. This process releases a tremendous amount of energy. The energy then travels outwards, eventually reaching the sun's surface and escaping into space. Understanding the sun is crucial for understanding our place in the universe. It's the closest star to us. This makes it a natural laboratory for studying other stars. By learning about the sun, we can learn about the lives of other stars and how they affect their planetary systems. Our solar system is home to 8 amazing planets. Each planet is unique and has its own special characteristics. The planets orbit the sun in a specific order. The closest planet to the sun is Mercury, followed by Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We can divide the planets into 2 main categories: terrestrial planets and gas giants. The terrestrial planets are the 4 rocky planets closest to the Sun: Mercury, Venus, Earth, and Mars. These planets are small and dense. They have solid surfaces that you could walk on if you could survive their extreme temperatures. The gas giants are much larger than the terrestrial planets. They are located in the outer solar system: Jupiter, Saturn, Uranus, and Neptune. These planets are mostly made up of gas. They don't have solid surfaces like the terrestrial planets. Jupiter is the largest planet in our solar system. Saturn is famous for its beautiful rings. Beyond the 8 planets, our solar system is teeming with smaller objects like dwarf planets. These celestial bodies are large enough to have a round shape due to their own gravity. However, they haven't cleared their neighborhood around their orbit. This means they share their orbital path with other objects of comparable size. The most famous dwarf planet is Pluto. Once considered the 9th planet, Pluto was reclassified as a dwarf planet in 2006. This decision sparked debate but highlighted the evolving nature of our understanding of the cosmos. Other notable dwarf planets include Ceres, located in the asteroid belt between Mars and Jupiter, and Eris, even larger than Pluto and residing in the distant Kuiper belt. The solar system isn't limited to planets and dwarf planets. Numerous smaller objects like asteroids and comets also orbit the Sun. Asteroids are rocky remnants from the early solar system. They mostly reside in the asteroid belt between Mars and Jupiter. Comets are icy bodies that originate from the outer reaches of the solar system. They often have elongated orbits that bring them close to the Sun. As they approach the Sun, their ice vaporizes, creating a visible tail. Section 4. Moons, planetary companions. Many planets in our solar system have moons. Moons are natural satellites that orbit planets and dwarf planets. Our own Earth has 1 moon, responsible for the tides and illuminating our night sky. Some planets have many moons. Jupiter, the largest planet, boasts over 70 moons. Its 4 largest moons, Io, Europa, Ganymede, and Callisto, are fascinating worlds in their own right. Io is the most volcanically active body in the solar system. Europa is covered in ice, and scientists believe it may harbor a subsurface ocean that could potentially support life. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. Callisto's heavily cratered surface provides a record of past impacts. Saturn is another planet renowned for its moons, with over 80 confirmed. Its largest moon, Titan, is larger than Mercury and possesses a dense atmosphere, making it a prime target for exploration. Section 5. Asteroids and comets, remnants of the early solar system. Asteroids and comets are like time capsules from the early solar system. They are leftovers from the time when the planets were forming. These objects offer valuable clues about the conditions and processes that shaped our cosmic neighborhood billions of years ago. Asteroids are rocky remnants. They are primarily found in the asteroid belt between Mars and Jupiter. This region is like a cosmic highway with millions of asteroids, ranging in size from small pebbles to dwarf planet series. While most asteroids stay confined to the asteroid belt, some have orbits that bring them close to Earth. These near-Earth asteroids are of particular interest to scientists because they pose a potential impact risk to our planet. Comets, on the other hand, are icy bodies. They originate from the outer reaches of the solar system, in regions like the Kuiper Belt and the Oort cloud. Comets are often described as dirty snowballs because they are made up of ice, dust, and rocky materials. When a comet's orbit brings it close to the sun, the heat vaporizes the ice. This creates a glowing coma, a cloud of gas and dust, and a tail that can stretch for millions of kilometers. Section 6. Beyond the planets, the Kuiper Belt and the Oort cloud. Far beyond the orbit of Neptune, our solar system doesn't just end. It extends into vast and mysterious regions populated by icy bodies. These regions, the Kuiper Belt and the Oort cloud, are remnants of the early solar system. They hold clues about its formation. The Kuiper Belt is a donut-shaped region. It lies beyond the orbit of Neptune. It's home to countless icy objects, including dwarf planets like Pluto, Eris, and Makemake. These objects are thought to be remnants from the early solar system, leftover building blocks that never coalesced into planets. Even farther out, extending up to a significant fraction of the distance to the nearest star, lies the Oort cloud. This spherical cloud is thought to contain trillions of icy objects. These objects are so far from the Sun that they are only loosely bound by its gravity. Occasionally, gravitational interactions with passing stars can nudge these icy bodies out of the Oort cloud, sending them on long journeys toward the inner solar system. These become long-period comets. The Kuiper Belt and the Oort cloud are challenging regions to study because of their vast distances. However, they hold valuable clues about the formation and evolution of our solar system.